Alright, the last toolkit entry of Chapter 2 is called the Pythagorean Theorem. And this theorem is named after a gentleman who's credited with having come up with it. His name is Pythagoras. And just for your own general knowledge, he came up with this about 500 BC, so about 2,600 years ago he came up with this. And it still lives today. And what it has to do with, it has to do with right triangles. So if you have a triangle, and it is a right triangle. Remember, if you don't see the symbol down here, it's not a right triangle here. So here's how his theorem works. What he said was, he said leg 1 squared plus leg number 2 squared equals hypotenuse squared. So let's look at the figure over here. The legs are the two sides that make up the right angle. This is leg 1, that's leg 2. You can interchange them, it's fine. It doesn't really matter which one you call leg 1 and leg 2, but they're the sides that make up the right angle. The side that's opposite the right angle is called the hypotenuse. And what we end up doing a lot of times in math is we abbreviate this. So we say the legs are A and B, and the hypotenuse is C. So the theorem that you may have heard before, and that most people know still today, is A squared plus B squared equals C squared. So that is the Pythagorean theorem. And remember, once again, this must be a right triangle for the theorem to work. Alright, so copy all this down, and if you need to pause, go ahead, and in a minute let's go ahead and work on how this might look in your math book with some examples here. Alright, first example. Find the missing side. So this is the missing side, obviously, your x, and what we need to do right now is we need to find it. How long will it be? And we're going to be using the Pythagorean theorem. So what I always tell my students is find the legs. So remember, the right angle is right over here. So the legs are the two sides that make up that. And so I circle them, so 6 and 7. So one of these is going to be A, one of these is going to be B. So I'm just going to call this one, I guess, A, and this one B. Doesn't really matter. And therefore the side opposite the right angle is C, the hypotenuse. So now we're going to set up and actually solve this here. So A squared plus B squared equals C squared. That's our theorem right over there. So I will say 7 squared, because that's what A is, and we square it, plus this side, the other leg, squared, 6 squared equals x squared. Now it's just a matter of simply solving this. Well, 7 squared is 49, 6 squared is 36, equals x squared. And I'm just going to go ahead and reverse things here on sides here. So I'm going to move the x squared to the other. So I have x squared here, and 49 plus 36 is 85. And then the last step that you need to do here is you need to go ahead and undo a square. So how do you undo squares? Well, you square root them. So I'm going to go ahead and square root both sides here. So x equals the square root of 85. And you can leave it that way and you'd be right. It's some number. Now we know the square root of 81 is 9, so it's going to be a little bit more than 9. You can also change it into a decimal. So if you were to grab your calculator right now and do the square root of 85, when you do that, you get 9.219544457. So what we typically do in our classes, we round it off to two places here. So we have on the calculator, I'll write it up here in blue, I have 9.2195. So based on that, if we were rounding off to two places to the nearest hundredth, that's this spot right here, would it stay at 9.21 or would it round up to 9.22? Well, the answer is 9.22. So what we do is we put equivalent to 9.22. So it's exactly the square root of 85, and it's approximately 9.22. So that's our answer here for the first one. Now let's take a look at another one here. Once again, you always want to go back and you want to look at the diagram and see which ones are the legs. So I'm going to go ahead and circle them right now. There's one leg, here's another. And you'll notice here, this time, the variable, the missing side that we're solving for is one of the legs, where in the first example, it was hypotenuse. So things are going to change a little bit here. So let's go ahead here and solve it using the Pythagorean theorem. So we'll take one leg squared, we'll call that A, and this one B. So we'll say m squared plus 9 squared, because that's the other leg, squared, equals the hypotenuse. The hypotenuse is 10, so 10 squared. Now it's just a matter of solving this algebraically. So m squared, 9 squared is 81, and 10 squared is 100. To solve this one, you're going to go ahead and subtract 81 on both sides. Subtract 81, subtract 81. And when we do that, we get m squared equals, and 100 minus 81 is 19. Then to undo the square, we square root both sides. So we get, in this case here, m equals the square root of 19. And that's exactly what it is. Once again, you can grab your calculator and actually do the square root of 19. So I just grab mine here, and we know that the square root of 16 is 4, so this will be a little bit above 4. And lo and behold, my calculator, when I did it, gives me 4.35889, etc., here. So rounding off to two places here, the 5 is in the second place, the 100th spot. So will this 8 make the 5 stay the same or round up? Well, it makes it round up. So it's going to be approximately 4.36. So either of these two answers would be acceptable, but it's exactly the square root of 19, and it's approximately 4.36. So that's how you do the Pythagorean theorem.